Monday. You guys, we were drawing these rectangles.
Can I go all the way?
So we're talking rectangles. I want you to draw yourself because I think, again, drawing these rectangles is sometimes the awkward part. You guys, they said we want to use just Riemann sums in general to order the areas from least to greatest. If I were to draw a left Riemann sum here, think it'd be an over or an underestimate. And if Nelson drew his rectangle this much bigger, I don't care. He still drew a left Riemann sum. You agree a left Riemann sum is looking like an overestimate. Agreed. What about a right Riemann sum?
Under.
Right Riemann sum is going to be an under. And then what about this one? The actual area under the curve. The actual is just referring to this shaded region. Isn't that going to be the exact area under the curve? So the actual is the exact area. They want us to list these from least to greatest.
Right, actual.
Right would be the least because it's the under. So I'm going to say that would be my least. A left would be the greatest. And then the actual would be the exact. So I want to scroll up then because yesterday I really left you up a creek without a paddle on those homework questions that you noted. When I was like, oh, it's going to be an over and under, and we didn't talk about it. Here's what I want you to do. An increasing function, I want us to draw increasing functions here. Is this an increasing function? Yeah, sorry, I feel like that's not really cute. You could just draw, oh, you could go linear for sure. Is this an increasing function? Yeah, one's concave up, one's concave down. It makes no difference. They're both increasing, right? You could go linear, both of them. Love that. A decreasing function, could that look like that?
No, left is an under.
Shh. And could this be a decreasing function? Yeah, so these are just different ways that we could just show increasing and decreasing. It makes no difference about the concavity is what I'm trying to hit right here. With this increasing function, if you drew a left Riemann sum like this, E, over or under?
Under.
Yeah, and all you have to say to our APE people is it's an underestimate because my function is what?
Increasing.
That's it. And they don't, yeah, it's just going to be increasing. They don't want concavity because the concavity doesn't matter, meaning, so if I were to say increasing this way, is a left still an under?
Yeah.
Yep. So, yep, the concavity does not matter. How about a right Riemann sum with an increasing function? Yeah. So I'm going to say a right Riemann sum is going to be an overestimate. And the only rationale you got to say, F is increasing. Do I have these memorized? I don't. Do I just draw myself a little picture and see it? That's all I do. I don't memorize these. You're welcome to, but obviously there's a lot of things that we have to memorize. This is one that I wouldn't say we need to. How about a left Riemann sum of a decreasing function? Yeah, I'd say this one's going to be an overestimate because my function is decreasing. That's the rationale that they want. How about a right Riemann sum then of a decreasing? He's saying this one's going to be an underestimate. Awesome. Yeah, you just visualize it. Agreed. You guys, on this guy, they want us to use a left Riemann sum. Did they give us a table? Did they give us a graph? No. They just gave us the function. Whoa. So you guys, let's try to visualize it. X squared looks like what? Plus 1. Right. So I'm just going to go plus 1. And I'm going to go whoop. And look what x to x they want us to find that area from. What x to what x? 1 to 5. So I'm going to go 1, 2, 3, 4, 5. That's what I'm going to do personally. And with only 4 subdivisions, right? So a left Riemann sum, if I went left, would I start at the 1 or the 2? Right, because that's the left-hand side. On the left-hand side, over, down. On the left-hand side, over, down. Left-hand side, over, down. Left-hand side, over, down. It is an underestimate. I wish that they asked us that because we'd be ready to say my function is increasing from 1 to 5. But they didn't. They just want an estimate of that area. Whew. Area, left Riemann sum. Okay, what kind of shape are we dealing with here? Rectangle. How do I find that base? Length times width. What's my base for all of these?
1.
Are we cool with do you want to just factor that out?
Yeah.
The base is the same for all of them? Okay, bear with me. What is the height of my red rectangle?
1.
When x is 1, how would I get my height?
2. 1.
You got to plug in when x is 1 right there, right? Yeah, so that's why I wanted to practice this. When x is 1, you agree that height is going to be how much? 2. Again, my base is still 1 for my blue rectangle. How would I get my height?
5.
When x is 2, 2 squared is 4 plus 1 gets me a height of 5. Of my green rectangle, when x is 3, how would I find that height? 3 squared plus 1 is going to get me a 10. And finally, when x is 4, are we done? Yeah. So you guys, look at what they gave you here. Oh, we just have this function, no picture this time. They want us to,
Actual right.
so they want us to figure out what is the least to greatest. Here's what you got to think about. What are those y values doing? Those y values are increasing. So I might be like, okay, my y values are increasing. I don't need anything accurately drawn. But is a left Riemann sum going to be over or under in an increasing function? These are increasing. You agree a left is an underestimate? So left is going to be the least. What about from the right?
That's going to be the most. Yeah.
That's going to be the most. That's going to be the biggest. What about the actual area? That's exact. That's the exact area. This has a trick, people. I'm going to read this and see if anyone can catch it. A tank contains 50 liters of oil at time t equals 4. Oil is being pumped in at a rate of, R is a rate, so that's a derivative in liters per hour. R is given above. Use a right Riemann sum with 3 rectangles to figure out the approximation of the number of liters at t equals 15. Right Riemann sum. What height are we not going to use? We're not using 6.5. Agreed. So what we did on Monday, 2 days ago. Let's see how we do. Well, and if we're using, they said, 3 rectangles. Would that be 1, 2, 3?
Yep.
Okay. What's the base of my first rectangle? Love it, Healed. The base of my first rectangle is 3. What's the right height? You know it. What's my next rectangle have a base of 5 and a height of? Love it. And my last one has a base of and a height of?
5.6.
Beautiful. This one's multiple choice. Gross.
Go get a chart.
Well, okay. Let's go and multiply these together. Here's how I handle this with decimals without a calculator. What's 3 times 6? 18. What's 3 times 2? 6. Move that decimal, and I'd have a 0.6, right? So I'd have an 18.6 there, right? What about 5 times 5?
25 times 6.
Oh, interesting way of thinking of it. Yeah. I want you to just think there are some other options to do just in case people struggle with this without a calculator. You could always just do 5 times 5. What's 5 times 9? 45. Throw that decimal back 1 because it was moved back 1. Then was 25 plus my 4.5? 29.5. And lastly, 3 times 5 is 15. 3 times 6 is 18. Move that decimal to the 1.8. Add them together, and we got 16.8. Margie, in my last class, Maggie Wessel, said, man, I'm just going to deal with the tenths and see if any of my decimals match up. 6 plus 5 is 11 plus 8 is 9. So she knows it's going to end in a 9. So we're digging A or C, right? If I add these up right here, I get 64.9, which is A, which is not the answer. Sammy, what are you thinking? They said, what is the approximation of the number of liters in the tank? And did it start with 50? Dang it. How annoying that this 64.9 is right there. You know what I mean? Like you did a right Riemann sum perfectly, but you didn't see that. So if I were you, as we read stuff, we got to give it a circle so that we don't forget to throw it in. Guys, here's what I want you to draw. Can you give me A parabola, give yourself some space. I gave you a big picture, a big blank for a reason because that picture's supposed to be there. Give yourself first quadrant. I drew that parabola, shifted up a smidgy for a reason. Okay. You guys, we've been using rectangles to estimate areas, and don't draw this point. You agree that a left-right Riemann sum is a pretty underestimate. A right Riemann sum is like quite an overestimate. The midpoint one's pretty good. What shape might be a little better? A trapezoid. So we're going to say, ooh, yeah, go trapezoid, go trapezoid, go trapezoid. Okay. Now, I do want you to split this. Let's go try to split this base into like 4 equal. I'm going to go in half and then in half again. Again, that should have been already on your picture. I'm so sorry. So I want us to practice drawing a trapezoid. Check this out. If I drew a trapezoid, I want you to go from the left point and the right point, and then I just want you to connect them. And what I've just drawn is technically, a trapezoid on its side, which might be hard to see right now, but then your next one would be, I'll do the next one in green. Here, here, here. Again, there's a trapezoid right there.
You can't really see it with a pencil.
Yeah, that's hard. That's hard. Here I'm going to go up. Here I'm going to go up, and then I'm going to connect them. And I'm going to do one more with red. No, I'm going to go yellow. I'm going to go up to the function, and over. All right. So if these trapezoids are on their side, what would you call this part of the trapezoid? That's the height. What about this? Height and? Okay. What about this? A base 1. I like that. What do we want to call that? Base 2. Oh, I got you. Okay. So here's what I want us to do. Let's go back this up. Okay. Here's what I want you to draw on your picture, you guys. Didn't you just say this would be the height? And this would be the height. And that would be a height, and that would be height of each of our 4 trapezoids. I dig it. And then, Mr. Greer, you said this is going to be our base 1. This little guy right here is base 1. That's a little b sub 1. Let me write it a little clearer. That's a b sub 1. What do we want to call this guy? B2. Okay, cool. Could I call that guy B3?
Yes.
Yeah, I'm just going to be different with them. I'm going to say all those bases are a little different. You down with that? And again, I'm just going to swivel it so you guys can see. Oh, now it's not together. Oh, crap. No more swiveling. That's okay. Here's what I need us to do. I want you to remind yourself, what's the area of a trapezoid?
1/2.
Yeah?
Plus base.
Base plus base times the, because the area of a triangle is 1/2 base times height. The area of a trapezoid is 1/2 bases times the height. When we say bases, Greer specified, add them, don't multiply them. I love that. You guys do agree, look at this picture. This is going to be quite accurate. A little over, a little under, would you say? A smidge over. Agreed. Okay, let's go find the area of this. Adding up these 4 areas of the trapezoid. This is a lot. So, Braddock, write small. Ready? The area of this first one is going to be 1/2. What was the height? What do we call the height here? H. It's on its side, right? The height is on its side. And then what were the 2 bases that we used for this guy? B1 and B2. So I'm going to say B1 and B2. What about my green trapezoid? What is its height?
H, B2, B3.
Yeah, my B2 and B3 are used now as my bases. Had I already used B2? Yeah, and that's okay. You can use it again. In trapezoidal, you'll use it again. Let's go to our third one. We got 1/2. What's the height of that one? Good. We got a B3 and a B4. And my fourth trapezoid is 1/2 the height times B4 and B5. And what I want you to notice was B2 used twice? Was B3 used twice? Was B4 used twice? Was B1?
No.
B5?
No.
Nope. So the endpoints are only used once, which is fine, because that's not doubled used at all, and everything else is used twice. Could I say, okay, this is the same as everything has a 1/2 H? Could I factor out a 1/2 H?
Yeah.
Could I say they all have a 1/2 H? I'm left with a B1. How many B2s? 2 B2s. How many B3s? 2 B3s. How many B4s? 2 B4s, and what else? 1 B5. Could you write it that way? Sure. To me, is that intuitive? Nope. Am I always just going to add up my individual trapezoids? Personally, I am, because I don't want to have this memorized. Will it always be the end plus the end and double all the middles? Yes. So if that sticks with you, go with it. Do you have to memorize it? Certainly not. Okay, so we're looking here. Graph of F is shown. You guys, I shouldn't have given you this question yet because we have not used this symbol yet. My bad. This is 6-3, which is tomorrow. Sorry about that. This is a integral symbol. So just like d dx was new, that's a derivative. This is the opposite. This is an integral. And all this is referring to is the area under the curve. So look at option A. It says, which of these is the least value? A is saying, hey, this is the exact area under the curve. So I want you guys to write that because we haven't seen that yet. And we'll get to that in 6-3. This is the exact area under the curve. Go ahead and write that down, Brady. They want the least. Guys, if I were to draw a left Riemann sum to approximate that area under the curve, 4 of them, if I drew one left rectangle, just to help myself visualize it, what are you picturing? It's going to be over, right? So I'm just going to write that there. That's over. They're looking for the least. What about a right Riemann sum? Under. That's a pretty big under. A midpoint. He's like, it's pretty close. Are you ready to say over or under? No. I'm not either. So it's like, it's pretty, I'm just going to say close. I'm not quite sure. And I saved this one for 6-2 because it says trapezoidal then. If I drew a trapezoidal.
I'd say that's closer.
A little over, a little under. Yeah, and I just drew one because if I drew multiples, it's going to just be a little under, right? So I'm going to write little under. You guys, they want to know which one has the least value. The right is the under. We feel like, dude, that one is under. You guys, now they're going to ask about concavity. Let's go graph. If something's concave down, happy or sad? Sad face. So we're like this. If something's concave up, it's happy. So let's just draw a couple trapezoids. If it's concave down, again, they don't have to be uniformed. You guys, a couple trapezoids, would you say over or under? Under. Yeah, and your reasoning would just be an underestimate because my function is what? Concave. Exactly, concave down. And then if I drew a trapezoidal rule with something that's concave up, yeah, this is going to be a slight overestimate. And again, they don't need the word slight. It's just an overestimate because my function is concave what? Up. That's all they need. So now we got to go practice. All right. Whew. Train is going back and forth. The velocity is given. Meters per minute. At time, they're being tricky again. At time t is 2, the position is 300 meters.
So you have to add 300 meters.
He's like, I'm going to circle. I'm going to pay attention to that. The train is moving east. Use a trapezoidal sum with 3 subdivisions, just means 3 trapezoids, to approximate the position when t is 12. Where did we start, Brady?
300.
We started at 300. Do we need to add that 300? I agree. Because guess what? So this is free response. So we don't, just throw it down so it's there. He's saying we got to add that 300. I agree. Guys, we've not done a trapezoidal from a table yet. Let's try it. You guys, and notice this. They only want 3 subintervals. And they said at 2, the position is 300. So start at 2. You guys, we're going to go like this. Boom, boom, boom. We got to start at 2. I love that, Soph. Good eye. Now, we haven't done this from a trapezoid, so I'm going to flip back to help us visualize this. The first base. Okay, sorry. The area of a trapezoid is 1/2 bases times the height. So I'm going to say 1/2. I'm just going to throw my height out front. What would the height of this first one be? Yes, between 2 and 5. 3 is good. what would be my first two bases? Don't shout it. So B1 and B2 are going to be 100 and what?
40.
Yes. My next trapezoid is 1/2 the height times the bases. My height is going to be between 5 and 8 is 3. The bases.
40 minus 120.
Will this 40 be used again? Yes. So we're going to say, all right, we got 40. And then because they didn't ask for total distance traveled, we can keep it negative. Love it. And my last one, 1/2, what's the height there?
4.
Good. The bases. Yeah, negative 120 minus 150 or plus negative. I dig it.
Leave it there.
We can leave it. Did I use my 40 twice? And did I use my negative 120 twice? Those are the middles. I used them twice, and the outers I didn't use twice. That's perfect. We are done as long as you put that 300 there. You know what I'm saying?
What about units?
Ooh, thank you. Did it ask for units? It didn't, but this is good practice. I dig it, Colin. I dig it. It'd still be 3 was minutes. Whoops. And then these were meters per minute. So what would be my unit? Good, because they're asking, hey, how far did it go? I do want you to know on one of your quizzes or tests or reviews, something's coming up that I saw the units were this, centimeters, and then this one was centimeters squared. So if I did centimeters times centimeters squared, what would be my units there? It'd be centimeters cubed, and they were asking for what my volume would be, and that makes sense. I just want to put it on your radar. They don't always cancel out. You know what I'm saying? It's on your radar. Love it. Let's try one more. Oh, smart. Okay, what did I ask for here? Trapezoidal, 3 trapezoids. Did I give you anything in the beginning to say that there happened to be a certain amount of tons in the recycling center to begin? Yeah. So, because there is no initial value, we're going to start at 0. I got a 1, I got a 2, I got a 3. Trapezoidal, 1/2 bases times the height. What do we want my first height to be?
2.
Good. What would the bases be?
16.
15 and 9. And don't forget, bud, just leave it. Now, granted, it's multiple choice, so you could say 24 there. But if it's free response, I'd leave it all just for that 5/6 rule and all that.
Yeah.
My next height,
5.
5. Bases, 9 and 5 or 14. Beautiful.
2.5.
And my last one is 2,
5 plus 4.
5, and 4. It's always base plus base. Yep. My halves are canceling out here, so I got a 24. Me personally, I'm not going to do half of 5 to get 2.5. I'm going to do half of 14 to get a 7 there. Times my 5 is 35. And then these halves are canceling with that 2 and plus a 9.
33.
68. Huh? You said